All right, the last one, quadratic formula. Complete square is always challenging, but there are other techniques to solve quadratics. So where do we stand right now? We have two ways of solving quadratics. We have the factored form, what two numbers multiply to -8 to add to 2. We factor it, we set each one equal to 0, we get our answer. The second technique is called complete the square. That's where we make a new c, we factor it, we take the square root of both sides. That was last night homework. All right, turns out, remember, factoring only works if it's factorable, so it only sometimes works. When it works really well, and it's the preferred technique. Complete the square always works. It's just that no one can seem to remember how to do it. So the reason why we have a third technique is because complete the square leads to a formula. I'm not going to show you that part of the class. We can do that in Algebra 2. But complete the square allows us to get to a formula that will always work for all quadratics, right? Factorable or unfactorable. So the final method of solving quadratics, if your quadratic is of this form, yes, it's going to play the music. I need you to copy this one down. Okay. Quadratic formula solves all quadratic, and it's just a plug and chug thing. So I'm going to talk fast. You're going to replay the video when you need to. So here's the start. You can use a quadratic formula always, 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 always. As long, that's the quadratic formula in blue, as long as the quadratic looks like this. It's got to look like ax squared plus bx plus c is equal to 0. If it doesn't, step number 1 is to make it look like that. There'll be a couple tonight for homework that don't look like that. Next, you identify the a, the b, and the c. The a is attached to x squared. Well, there's nothing attached to x squared except for 1. The b is the number attached to x. Well, that's a positive 7. And the number that's in the c position is 12. So I would highly recommend that you write those numbers off to the side. And then it's just plug and chug. From left to right, from top to bottom, you plug in the numbers. B is 7, so -7 plus or minus the square root of 7 squared minus 4 times 1 times c, which is 12. Where did I get those numbers from? From the red. Where did they come from? From the fact that the original equation was set up in the form ax squared plus bx plus c is equal to 0. All over 2 times 1, 2 times a. Now we follow PEMDAS and we simply simplify. You can do this in the order that you choose as long as you don't violate the rules. I usually square first. 7 squared is 49. Then I do the multiplication. 4 times 12 times 1 is 48. And 2 times 1 is 2. I do the inside of the square root next. 49 minus 48 is 1. I take the square root of 1. The square root of 1 is 1. That gives me two equations. -7 minus 1 over 2 and -7 plus 1 over 2. And then I simply do the math. -7 minus 1 is -8. -8 divided by 2 is -4. -7 plus 1 is -6. -6 divided by 2 is -3. So I get a -4 and -3. All we're going to do now is examples. As long as the equation is this form, right? This form, this form, this form. Step number 1, pick out A, B, and C. A is 2, B is 3, C is -5. Be careful with the negatives. And then I just plug the numbers in exactly the way that formula appears there, over there to the right in yellow. -3, because that's the B value, plus or minus the square root of 3 squared minus 4 times 2 times -5. That's just 4AC. All over 2 times 2, because A is 2. Square 3, you get 9. 4 times 2 times 5 is 40. Negative times a negative is a positive 40. 2 times 2 is 4. 9 plus 40 is 49. The square root of 49 is 7. Write your two equations. -7 minus 7 over 4 and -7 plus 7 over 4. Do the math. -3 minus 7 is -10 over 4. That would be what? -5 over 2. And -3 plus 7 is 4 over 4, which is 1. So we get -5 over 2 and 1. Play this again over and over and over again. I'm talking super fast. Play this again over and over and over again. Another one. As long as the equation looks like ax squared plus bx plus c. A is 1, b is -2, c is -8. Toss the numbers in. I'm just going from left to right, top to bottom. -2. Hey, that would be a 2. -2 squared would be 4. 4 times 8 is 32. A negative times a negative is a positive, so plus 32. 2 times 1 is 2. 4 plus 32 is 36. Square root of 36 is 6. Write your two equations. 2 minus 6 over 2 and 2 plus 6 over 2. 2 minus 6 is -4. 2 plus 6 is 8. -4 divided by 2 is -2. 8 divided by 2 is 4. So we get -2 and 4. Another. Oh, here's our first one. We got a problem. It doesn't look like that. C is on the wrong side. So move C to the other side so it says 0. Subtract 21 from both sides. Now it looks the way it's supposed to look. A is 1, B is -4, C is -21. Plug and chug. Plug them in. -4 plus or minus the square root of -4 squared minus 4 times 1 times -21 all over 2 times 1. I'm just looking at the formula, looking at what there is in red and plugging in the right values. -4 is 4. -4 squared is 16. 4 times 21 is 48. Negative times a negative is positive, so plus 48 all over 2. 16 plus 84 is 100. The square root of 100 is 10. So we get 4 minus 10 over 2, 4 plus 10 over 2. 4 minus 10 is -6 over 2. 4 plus 10 is 14 over 2. -6 divided by 2 is -3. 14 divided by 2 is 7. There we go. There are all of your examples of using the quadratic formula. If you have any questions, ask me. If not, I'll see you in class on Monday.